We are now looking at Pascal's principle. Some time back, we said pressure has SI units, and the SI unit is Pascals. Now, Pascal is actually a name of a person. So let us look at Pascal's principle. How did he state his law? How did he state the principle? So as question A guides us, state Pascal's principle, and it is 1 mark. So Pascal's principle states that pressure at a point, you could also say pressure at any point, pressure applied at a point, all those are accepted. Pressure at any point in an enclosed fluid is transmitted equally in all directions. Pressure at a point applied at a point in an enclosed fluid is transmitted equally in all directions, and you get your mark. Now, here we are saying when you get a fluid, which could be a liquid or a gas, enclose it. Enclosing means you put in a container and you seal it. Then if you apply pressure at any point, the pressure you have applied is going to be transferred. It is going to be transmitted throughout the whole fluid equally in all directions. Where do you apply this principle? Now, Pascal's principle sometimes is also called the principle of pressure in fluids. So if somebody says state the principle of pressure in fluids, it is the same as saying state Pascal's principle. So, supposing somebody said state 2 applications of Pascal's principle. We have them here, applications of Pascal's principle. One is in a hydraulic press, and another one is in a hydraulic brake. Now, all these are machines, but they use Pascal's principle in their operations. So Pascal's principle is used in hydraulic press and hydraulic brakes. We are going to look at the hydraulic press in a short while, but before that, I want to remind you that the hydraulic brake is the same as the braking system of a vehicle. So another name for a car brake is a hydraulic brake. Now let us begin with the first one. That is the hydraulic press. What is a hydraulic press? How does it look like? And where is it being used? Now, a hydraulic press, just as the word says press, it is used to press clothes, especially second-hand clothes. You know, second-hand clothes normally, they are packed in bales. So if you want to squeeze them to press them together, you use a hydraulic press. So a hydraulic press is used to press second-hand clothes in bales. We also use it in car garages, in a garage, to lift cars. If you have ever seen a car lifted up in a garage, then that was a hydraulic press doing it. So let's look at briefly, before we look at how the structure is, let's look at the uses. We are saying it is used to lift heavy objects using a small force. For example, in garages, to lift cars. You see? So you use a hydraulic press to lift heavy objects. A vehicle is a very heavy object, but you can lift it using a small force. Now, the small force you apply is called the effort, and the heavy object you are lifting up is called the load. So the effort, use a small effort to lift a big load, which is actually the work of a machine. To simplify work, use a small force to lift a big load. For example, in garages, to lift cars. Another interesting thing about this machine is it is a multiplier of force. Supposing you have a small force, that is the effort, as small as 2 newtons. but you are using it to lift a big object, that is the load, and maybe it is as big as 1000 newtons. Just imagine 2 newtons lifting 1000 newtons. How many times do you think 2 newtons can go into 1000? You get that by dividing 1000 over 2, and you get 500, which means the effort has been multiplied 500 times to get the load. So for that reason, we are saying a hydraulic press is a multiplier of force. Let us get that explanation in the form of an example. And our example says, find the force exerted at piston B of the hydraulic press shown in the diagram below. Find the force exerted at piston B of the hydraulic press shown in the diagram below. So this is the diagram that the question is talking about. This diagram shows how a hydraulic press looks like. You realize that a hydraulic press has majorly two sides. This side is bigger than this side. You can see this area. This is big. This one is small. Now, it has two pistons. This is the piston, and this is also the piston. So there is a piston on the smaller side. There is also a piston on the big side. So the piston on the smaller side is where the effort is applied. Then on the bigger piston, this is where the load is lifted up. Now, how does this thing work? We have said it has pistons. We have given them names, piston A and piston B. Now, the force which is applied here on the smaller piston is called the effort. But the force which is raised up is the load. So when you press down, what happens? You are using a force. When you press this piston A down, the force you are applying is going to create pressure. That pressure is going to be transferred on the fluid. Inside here we have a fluid. Now this fluid could be a liquid or a gas, but normally we use a liquid. Now when you apply force here, like here we are using 200 newtons to press, you press down, you see the direction, you press down. That force is going to create pressure. That pressure is going to be transferred to the fluid, and the fluid will transfer the same pressure, transmit it from side A to side B, from piston A to piston B. So the same pressure is going to be transmitted, and that is Pascal's principle. So this machine uses Pascal's principle, which says that pressure applied at a point, you see, when you apply pressure on one point in an enclosed fluid, this fluid is enclosed, you see, it is sealed. This side is sealed, this side is also sealed. So when you apply pressure at a point, what happens? That pressure is going to be transmitted equally in all directions throughout the fluid. So when you apply this effort down, you press here down with 200 newtons. That force is going to create pressure. Pressure is going to be transmitted by the fluid from piston A to piston B, the same pressure. And now when you look at the question, we are supposed to calculate the force at B. There are two forces. This side the force is called the effort, which we have been given, but this side the force is called the load. So we are supposed to calculate the load, the force at B, but we have been given the force at A. So when you press here down, the pressure is transmitted, and that pressure will force the load to move up. So we are supposed to calculate this force, which is actually the load. So what are we going to do? We are going to quote the principle. We are going to begin by stating the principle of the hydraulic press, that is Pascal's principle, by saying pressure applied at a point is transmitted equally in all directions. Remember, this piston has a small area. You see, 0.05 meters squared. So we are given force and area so that we can calculate the pressure here. But that pressure is the same because it is the one which is going to be transmitted this side. But here we have given the area. Here the area is bigger, 1 meter squared. And they want us to calculate this force, which is the load at B. So what are we going to do? We are going to say, since pressure at any point in a liquid acts equally in all directions. You see, we begin by quoting the principle on which the hydraulic press operates. It means pressure at A, piston A, is equal to pressure at piston B, because the pressure this side is the one which is transmitted this side. So the same pressure. So the pressure at A is equal to pressure at B. How do you calculate pressure when you are given force and area? We all know that pressure equals force over area. So we have two pressures, pressure at A and then pressure at B. So we shall say force over area for side A, that is the pressure at A, is equal to force over area for side B. Now remember, there are two pistons, piston A and piston B. So on piston A, we are going to call the force, force 1, and it is area, area 1. Then on the side of piston B, we shall call the force, force 2, and then area 2. Then we now substitute. Now this is our formula. Now we substitute. Remember, we are given force. The first force, that is force 1, 200 newtons, and the area is 0.05. So we substitute that. But this side, they have not given us force, so force 2 is not given, but area 2 is given as 1. So we are going to substitute. Where there is force 1, we write 200. And we divide by the area 1, 0.05. Then force 2 is what we are looking for, but the area 2 we are not given. Okay, we are given, it is 1. So you substitute. Now when you divide F2 divided by 1, it remains F2. And when you divide 200 by 0.05, you get 4,000. Now what is going to be the units for force 2? The unit for force 2, that is the force at B, is the same as the unit for force 1. If this one is in newtons, the effort is in newtons, then the load should also be in newtons. Just as the areas also have the same units. Meters squared, you see, 1 meter squared. This side we have 0.05 meters squared. Area 1 should have the same units like as area 2. So in the same way, force 1, which is the effort, must have the same units as force 2. So after calculating force 2, your units should be newtons. So when you divide this, your answer is 4,000 newtons. That is the force 2, which is the force at B. Now, we are going to compare these two forces. Force 1 was, what was force 1? It was 200. But force 2 is 4,000. What does that mean? You use a small effort to lift a big load. Remember, 200 is less than 4,000, which we have got. Use a small effort to lift a big load, which is actually the work of a machine, to simplify work. In the same way, I want you to compare the 200 rather with the 4,000 still. How many times do you think 200 can go into 4,000? You get that by dividing the bigger figure, which is 4,000, which you have just calculated, divided by 200, and your answer becomes 20, which means the effort has been multiplied 20 times to get the load. And that means a hydraulic press is a multiplier of force. So we shall say, thus, a force of 200 newtons at A produces a force of 4,000 newtons at B. This shows that a hydraulic press is a multiplier of force. Now, I want to share with you some key information concerning this question. Sometimes when questions are set like this, you may be needed to do the following. You need to state the principle, in this case the principle of the hydraulic press, and that is what we started with. Write the formula, write the correct substitution, calculate and get the correct answer, and get the units. So, in the marking guide, when they are marking, these are the things the examiner will be looking at. So if you started from the formula, you will miss the marks for the principle. So sometimes some questions are set in such a way that you need to state the law, the principle. So if there are 5 marks, they will give you for the principle or for the law, for the formula, for the correct substitution, for the correct answer, and the correct unit. Now, the second application of Pascal's principle is the hydraulic brake, which is actually the car brake. So we begin by showing you how the braking system of a car looks like. Now there are some major parts which you need to know, and one of them is the brake pedal. The brake pedal is also called the foot pedal. This is where the driver steps. So when you want the car to stop, you step here. So this part is called the brake pedal, or you can call it the foot pedal, because this is where you step. Next to the brake pedal, you have a cylinder, which is called the master cylinder. There are so many cylinders in a car, but there is a cylinder which controls all of them. We call it a master cylinder. Just as sometimes you may have master key, a key which can open even when other keys are not there. You have a key that is called a master key. So we have very many cylinders in a car. This one is called a master cylinder. Now inside the master cylinder, we have a fluid, the one which is supposed to transmit pressure in all directions to all other wheels or to other cylinders. So you have a fluid, and that fluid is called the brake fluid. Now, this brake fluid is the one which is supposed to supply pressure to all other wheels in a car, depending on the number of wheels that car has. Now, supposing this is one of the wheels somewhere down here, every wheel must have what we call a wheel cylinder, and every wheel cylinder has a piston. So these are the main parts. You have the brake pedal, the master cylinder, you have the brake fluid, which is, this one is connecting to other wheels, and then every wheel must have a wheel cylinder, every wheel must have what we call the brake shoe, there is what we call the brake lining, and then we have a return spring. It is a spring, but they call it a return spring. I will explain why it is called a return. Now this is the diagram of a hydraulic brake, the braking system of what? A vehicle. Now the next question is, how does it work? Now for us to understand how a hydraulic brake works, the whole thing starts with the foot pedal. When you step here, remember when you want the vehicle to stop, you step on the brake. So when you press the brake pedal by stepping, you are applying a force. That force is going to be transferred to the master cylinder. Remember, in the master cylinder, there is a fluid, which we call the brake fluid. So that force has pressure, and that pressure is transmitted to the brake fluid, which is the fluid there. So this fluid is going to supply the same pressure in all directions, depending where the wheels are. But it will supply the same pressure which means the pressure will be equally transmitted. So the same pressure which was exerted on the master cylinder from the foot pedal as you stepped here is the same pressure which is going to be transferred to all other wheels. Now remember, every wheel has a wheel cylinder, and inside the wheel cylinder there is a piston. So when the pressure is transmitted to the wheel cylinder, what happens? The piston of the wheel cylinder opens. And when it opens, this part here expands. You see? This brake shoe, the brake shoe opens, opening like this. It becomes bigger. And when it opens, this brake lining is going to touch the tire which is rotating. And when this one touches, the tire will stop rotating. And this is what is going to happen to all the tires, because the same pressure is supplied to all of them. So they will all stop at the same time. Now, what happens when you remove your foot from the brake? When you remove your foot from the brake, remember, the brake shoe had opened, it had expanded. So what happens? It is now the work of the spring to return. You see, that's why we are calling it the return spring. So it is the work of the return spring to do what? To bring back the brake shoe. Remember, it had gone this way, expanded, now it comes back. And when it comes back with the brake lining. The brake lining will also come back. And when the brake lining comes back, it now releases the what? The tire. It stops touching the tire. So then the tire begins what? Rotating. So all the tires will do the same thing. So that is how the hydraulic brake, which is the braking system of a vehicle, how it works. Now we can put that in words and say it works on the principle that pressure at any point in a liquid acts equally in all directions. Remember, that is the principle, that the pressure applied at any point in a liquid acts equally in all directions. And the next statement says the fluid used is brake fluid. So the first statement is the principle. The second one is the name of the fluid used. Now let's move further. Let's move further and see what happens. When the foot pedal is pressed, the resulting pressure in the master cylinder is transmitted to the wheel cylinder. When you press the foot pedal, there is a pressure exerted. That pressure is exerted on the master cylinder, transmitted to the other wheel cylinders. So the piston of the wheel cylinder opens up the brake shoe. You see, the piston of the wheel cylinder opens up the brake shoe. And then what happens? The brake lining stops the wheel from rotating. When you remove your leg from the foot pedal, on releasing the foot pedal, the work of the spring, that is now the return spring, is to force the brake shoe back. And when the brake shoe comes back, the brake lining stops touching the wheel. And then the wheel will be free to rotate.